All right, so this is lesson 4. This is the composition of functions. After this lesson, you'll do the review, and then you will take the Unit 6 test for radicals. So the first part is a warm-up, and it's just a review of inverse equations and how we find the inverse of equations. And this is composition. This is composition where we substitute an equation. So we're not substituting a number. We substitute an equation into another variable. So what are the steps to finding the inverse of an equation? Well, first, let's say we have our equation. We have our equation. The first step is to change the x and y. So what does that mean? They change the x and the y. So where that y is yellow, we're going to replace it with x. And you can see below they exchange the x's and y's in this equation. So if you follow that first step, you're on the right path for finding the inverse of a function. So then the last step is to solve for y. So we're going to do that. We're going to just do the 2 steps here. We're first going to describe the type of equation that we have. This is y equals 3x minus 1. The x is to the 1 power. So this is a linear equation. This is a linear equation. Secondly, we exchange the x and y. So here, x equals 2y. I'm sorry, looking at the first equation, my bad. So x equals 3y minus 1. And then we solve for x. So I'm going to add 1 to both sides of this equation. These are not like terms. X and 1 are not like terms, so it becomes x plus 1 equals 3y. 1 minus 1 is just 0, so it goes away. And then to get y completely by itself, we divide by the coefficient, which is 3. You can do both terms here. You can divide both terms by 3. From left to right, you have x, or 1 over 3. This becomes 1 over 3 times x plus 1 over 3 equals, this cancels, y. And this is how you find the inverse. So the 2 steps that we followed, we exchanged x and y, and then we solve for y. So looking at equation number 2, it's to the 2nd power. It's x to the 2nd power. This is a quadratic. This is a quadratic. And what we're going to produce is a radical. You'll see when we find the inverse. So the inverses of quadratics are radicals. Inverses of quadratics are radicals. So exchanging the x and y, so I have x equals y squared minus 1. In order to get y by itself here, we're going to add 1 to both sides. X and 1 are not like terms, so we have x plus 1 equals y squared. In order to get rid of a square, we use the square root radical. We use the inverse. And it covers the whole quantity of x plus 1, so you make sure we end up with the square root of x plus 1 equals y. Okay? And what we'll find here, we can say plus or minus. We always want to say that when we're finding the radical. But we found when we've settled that part, but we found the inverse. Now let's discuss the type of inverse that these equations are. The first one is linear because there's an x at the top and it's to the 1 power. The second one is linear as well. And then the inverse type down here is a radical. It's a radical. So important things that we want to keep in mind. Now the cube root function, the type right we have here is a cube root. The cube, it's a cube, it's a cubic, we call it cubic polynomial. And the inverse of that is going to be the cube root. So that's actually what I meant. So first step, exchange x and y. Okay, subtract 8 on both sides of this equation to solve for y. To produce x minus 8 equals y cubed. This goes away. Take the cube root. Make sure you put the cube root of both sides of this equation. We end up with the cube root of x minus 8. All of the quantity there is underneath that cube root equals y. And we don't have to consider plus or minus here. The inverse type is a cube root. Radical. It's a radical. It's a radical function. We can be very specific about that type of function. Next, number 5, y equals the square root of x minus 5 plus 1. So the first thing we do, we're not going to touch this part when we're solving for what we need to solve for. We have to get rid of that 1 first. But first, let's exchange the x and y. So x equals the square root of y, y minus 5 plus 1. We can't do anything until we get rid of everything outside of this radical, of this quantity, right? So we're going to subtract 1 on both sides. I have x minus 1 equals the square root of y minus 5. This goes away. We're going to square both sides to get rid of that radical. I have this x minus 1, the quantity of x minus 1 squared, equals y minus 5. The radical drops away because that squaring it cancels it out. I add 5 to both sides of this equation, and I end up with the quantity of x minus 1 squared plus 5 equals y. This goes away as my inverse. And this inverse produced is a quadratic. So you can see that the quadratic has an inverse that is a radical, and the radical has an inverse that is a quadratic. And can't forget to put the type of function that this is. Next, this is a cube root. So at the end, we should cube root radical. This is a square root radical. At the end, we should produce a cubic polynomial as its inverse. So first, we exchange the x and y. So x equals the cube root of 2y plus 4. Recube both sides of this function. End up with x cubed over here on the left. On the right, the cubic root falls away, and we're left with the quantity of 2y plus 4. We subtract 4 on both sides. Obviously, these are not like terms, x cubed and 4, so it becomes x cubed minus 4 equals 2y. Then we divide both sides by 2. I like to divide individual terms, producing x cubed over 2 minus 4 divided by 2 is 2 equals, this cancels, y. And we have produced a cubic polynomial because we have x to the cube power. And that's an overview of the warm-up for this lesson. So we're going to move on to the actual composition of functions. So for my quadratic, we're going to use this table to graph the quadratic parent function, and then switch the x's and y's to graph the inverses of it. So we can, if we're given a graph, so given an equation, we can use x and y values to produce an inverse graphically. This is graphically. Before we did algebraically. So what we're going to do, we're going to use this function, y equals x squared, and we're going to go to our graphing calculator, press y equals, type in x squared, and go to second graph for our table. And what we'll find is if we use our table, there's our values. So we have 9, 1, 0, I'm sorry, 9, 4, 9, 4, 1, 0, 1, 4, right? So I'm going to go ahead and graph these points. So the first point, I'm going left 3, up 9. So left 3, up 9, make a point. Left 2, up 4, make a point. Left 1, up 1, make a point. And then 0, 0 stays at the origin. Right 1, up 1, right 2, up 4. And this is symmetric, right 3, up 9. I create my curve. And I'm going to refer to this as my quadratic. I'm just write a little Q there so I know. And now we're going to go and do what I told you before, which is switch those x's and y's, because I have them labeled here, to produce my inverse. 9, negative 3, 4, negative 2, 1, negative 1, 0, 0, 1, and 1, 4, and 2. So I have right 9, down 3, make a point, right 4, down 2, okay, right 1, down 1, and then here at 0, 0, I have a point. Then right 1, up 1, right 2, right 4, up 2, right 9, up 3, and I create my graphic here, and it looks like quadratic as well, but this is my inverse. I'm going to put a little I there. So we just produced the compositions of functions by switching the x and y and identifying the quadratic and its inverse. The cubic works similarly. So this time we're just going to cube the numbers. So negative 3 cubed. We don't have to use our graphing calculator to produce these numbers. And that produces negative 27. Negative 2 cubed. It's negative 2 times negative 2 times negative 2 produces negative 8. Negative 1 cubed produces a y value of negative 1. 0 cubed produces 0. 1 cubed produces 1. And 2 cubed produces 8. Now, graphing these values, I can't graph the first point, negative 3, negative 27, but I can graph negative 2 and up, negative 8. I can graph negative 1, up and down 1. I'm sorry, negative 2, down negative 8. So negative 2 down negative 8. Negative 1, negative 1. 0, 0, 1, 1, 2, up 8, and I create my curve. It's a curve. It's not a straight line. Okay. Now for our inverses, all we do is switch the x's and y's. So I have negative 27, negative 3, negative 8, negative 2, negative 1, negative 1, 0, 0, 1, 1, 8, and 2. Okay. So let's graph. We can't graph the first one, but we can graph negative 8, negative 2. We can graph negative 1, negative 1, 0, 0, 1, 1, 8, positive 2. Create my curve, and this one looks similar, except it's going, it's rotated. It's rotated. So for cubics, they're rotating about 90 degrees, and quadratics rotating 90 degrees. So rotate 90. Yeah. Sorry, 270. They rotate 270 degrees. Number 3 says the graph of function g is shown on the following grid. This is a radical. This is a radical. So the opposing side should produce a the inverse should produce this rotated 270 degrees. And if I rotated that 270, first it would go down, then it would go sideways the other way, then it would come back up. So it's probably going to do this one, but we're going to make sure by just checking some of the values. So my first value is 4, 0. So if I switch those graphically, it would produce 0, 4. It would produce a point 0, 4. So my inverse would start here. It started 0, 4. Sorry, 0, 4. It's right up here. The next point I would have would be right 3, up 1. Inverse would be 1, 3. So right 1, up 3. Okay. Another good point I have on here is looks like 0, 2. Inverse would be 2, 0. So I graph that point, and it looks like it's going to look like this. And it looks like I was incorrect, and this is actually the correct answer. So we got to be careful and cautious about how we look at rotations that occur. All right. So moving on. All right. So